Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at the topic sulfur and its compounds, and you're going to be looking at the extraction of sulfur. So we'll look at the large scale extraction of sulfur, and then you get a chance to do one or two questions. So sulfur usually takes the form of a yellow solid and it can naturally be found near volcanoes. So it's mostly near the volcanoes, like some that are active, others that are not. And it's yellow in color as you can see from the image. It's also present in a number of metal ores such as zinc blende. Actually, zinc blende is one of the major ores of sulfur and its chemical symbol is S. So you're going to see us writing S, especially when we're writing the equations. It has 16 protons and 16 neutrons, so it is atomic number 16. And it has a mass number of 32 and atomic number of 16. It's an nonmetal and exists on the earth crust either as pure sulfur or a metal sulfide. And the most common one is zinc blende or zinc sulfide. It's placed in group 6 of the periodic table just after phosphorus and below oxygen. And it's found as a free element or in combined state, just like we have said. In free element, free sulfur is found at a large depth below the Earth's surface. And of course, that is where our major focus will be today. And then also it is found in combined state. As we said, the main is zinc sulfide, but we have others like copper pyrites, galena, we have iron pyrites, as you can see. So it's also found as a gas, hydrogen sulfide gas. We're going to discuss about this gas later on as well. So let's look at the extraction of this pure sulfur. It's extracted by a process called fresh. It uses three mining techniques. There is the conventional underground method, there is conventional open pits method, and there is now the fresh process, which is the underground melting process. So fresh process was invented by someone called Hermann Fresh. He was a German American person. So this is how the process looks like. So you can see our molten sulfur is on the ground, but it's not doesn't exist as molten state. You'll see why it turns molten. So you notice in this process we have three pipes that are when the hole is dug, they are inverted inside the hole into where the molten sulfur is. So we have the outermost pipe, we have the innermost pipe, and the middle pipe, as you can see. And each pipe has its own function in the process of extracting. So we'll start with the fact that sulfur is not mined by conventional means because it usually lies very deep, especially if we want to get the pure sulfur that is not in combined state. So it can't be easily accessed. It's so deep into the layer inside the soil, so it's accessed by underground melting. So sulfur also deposits are associated with poisonous gases such as sulfur oxide, which can cause massive pollution if exposed to open environments. And then, so we said there are three concentric pipes that are usually drilled through the rock to where the sulfur deposits are. So let's look at each function of each pipe and how exactly we extract the sulfur. So we have the outer tube or pipe. So basically we are looking at this gray one on the outer side. So let's see what's the function. It is usually used to pump superheated water, and this water is heated at 170 degrees Celsius and at 10 atmospheres. So it is superheated under specific pressure, and the pressure is 10 atmospheres. The high pressure usually ensures that the water remains at liquid state at high temperatures instead of vapor and gas. So we discussed this in Form 1. If you have like high pressures, the boiling point increases for water. So it remains in liquid state although the temperatures are very high. So the water helps in melting the sulfur because the melting point of sulfur is lower than what you have in the water. The water is 170 degrees Celsius, but the melting point of sulfur is around 150 degrees Celsius. So by the time the water reaches the sulfur, its temperature drops to 120 degrees Celsius, but it's enough to melt sulfur, which melting point is 114 degrees Celsius. So that is the function of the outer pipe. And then we have the innermost pipe as well. The innermost pipe is the smallest of the pipe of all the pipes. It is used to blow uh, or force a jet of hot compressed air, and it is compressed about 15 atmospheres down the sulfur deposit. This produces a light froth of molten sulfur. So this froth is a mixture of air, water, and sulfur, which helps it now to be forced into the middle of the pipe. So the middle pipe now allows the froth, now the mixture of sulfur, water, and air, into the surface where the mixture is run into large tanks. And then the froth settles in two layers because you know that sulfur does not dissolve in water. Its density is it's very dense, doesn't dissolve that easily. So the bottom layer is usually mainly water, while the upper layer is molten sulfur due to the different in densities. Once in settling tank, sulfur solidifies and separates out and gives a very large percent of pure sulfur. Sulfur is removed, melted again, poured into molds to form oil, raw sulfur, which is a form it is in solid. So those are the functions. Just to recap, remember the outermost pipe, we add superheated water at 170 degrees Celsius that is also under pressure of 10 atmospheres. The pressure is to help the water to remain in liquid state. And then the innermost pipe, hot air is blown. This hot air is compressed to 15 atmosphere, and it reacts with the sulfur and water to form sulfur froth, which is a mixture of sulfur, air, and water, which pushes now this mixture into the inner pipe that now is collected on the top. So let's do a few questions. You do just one question. So the diagram below represents the extraction of sulfur by fresh process in Louisiana, USA. So name substances that passes through tube 1 and tube 2. So you can see the first tube is the inner tube, and then we have the middle one, and then we have the outer one. So tube 1 is the middle and tube 2 is the outer one. So we know that the outer tube is tube 2, which allows superheated water of 170 degrees Celsius and 10 atmospheres. It's important if you know these conditions, you put them. Otherwise, if you're not sure, do not put them down. Otherwise, you might get it wrong. And then tube 1 is the middle one. The middle one is where the sulfur froth comes out. And remember, we said the sulfur froth is a mixture of sulfur, air, and water. All right, and then the next question is, what's the purpose of the hot compressed air? So remember, first of all, the hot compressed air, first of all, it helps to push the sulfur, the molten sulfur outside through the inner pipe in froth. And then it also helps to maintain the temperatures of water, or basically it keeps the sulfur molten. Because you can imagine we keep on pumping the hot water, but at some point it starts cooling. So if we add hot compressed air, it's not only going to help to push the sulfur out, but also keep it in molten, so like it doesn't cool. If it's cooled without it moving outside, it's going to block this inner pipe. So that's the question. You can get more questions after this video. You can check out more questions and you see how they are going to be answered. So that brings us to the end. So in the next lesson, we are going to be looking at the allotropes of sulfur and how they look like. So see you in that lesson.